For our next device, we are going to use shift registers. Now, shift register has multiple applications, but it's primarily used in serial communication. The first bit comes into the register over the serial line and is stored in the least significant bit. Now, it can be the most significant bit if you want, but the point is it starts at one end of the byte. The next bit comes down the serial line, and the register shifts the previously stored bit over one spot. It then stores the new bit in the first bit of the byte. As the next bit comes in, once again, it shifts all of the previously stored bits over one and stores the next bit in the lowest location. As each bit comes in, it shifts the bits over one until the whole register is full. You now have an 8-bit number available on the parallel bus within the electronic device. These shift registers can be any number of total bits, but in the case of the board we're about to use, it is an 8-bit register. Now, what I demonstrated here was a shift-in register. We're shifting bits from an external source in to the register. You can also get a shift-out register, which is simply the opposite process. A byte of data is loaded into the register from a parallel bus and then shifts the data out one bit at a time down the serial line. There is a corresponding clock line which synchronizes the serial communication with the register shifting. If the register is shifting out, then a clock pulse is generated when the bit is shifted out from the register onto the data line, and the recipient shift register locks and loads that bit into its register. Because there is a synchronizing clock pulse, there is a lot of freedom in timing here. You can go really fast or really slow. It doesn't matter because there's a synchronizing clock. So you can have two devices of very different capabilities as far as speed goes, and they can freely communicate with each other. You can shift in least significant bit first, or you can shift in most significant bit first. Obviously, you have to decide that, but in general, the speed of transmission does not have to be agreed upon between the two communicating parties. You can buy shift registers on a chip, like the TTL 74LS166, or most microprocessors have them as well. Okay, let's put some shift registers to use in the next lesson.